Let's solve question 2 now. So we have a function f of x squared minus 6x plus 8 divided by x squared minus 5x plus 6. And we have two questions based on it. We want to know where is this function continuous, and we also know where is the limit as x approaches a certain number a of f of x. So where can we define this limit? So let's solve first things first. Let's go through the continuity part. Remember, what is the definition of continuity? Well, for a function to be continuous, we want that the limit as we approach that specific point equals to the function at that point. So in our case, if we substitute a into our x, what would we have? Well, in our case, we would have that the limit as x approaches a of f of x would equal to a squared minus 6 times a plus 8 divided by a squared minus 5a plus 6. And we want this value equals to f of a. And what would be f of a? We would substitute a into x. So we would get the same thing. A squared minus 6a plus 8 divided by a squared minus 5a plus 6. Okay, this is the shape of our function that we want. But then remember, what is continuity about? Continuity is about having defined values along the axis. Now, this is a division, and let's remember that division by 0 is undefined. So we cannot have this thing equals to 0. In that case, the function will not be continuous. So the function is continuous everywhere except on this range. So a squared minus 5a plus 6 different than 0. We cannot have 0. What would be the values that cannot be accepted? Well, let's solve this as a quadratic equation. Let's use our shortcut where we take a, two numbers that we multiply and get 6, and when we add we get minus 5. Well, if we take minus 2 and minus 3, minus 2 times minus 3 is 6, and then if we take minus 2a and minus 3a, we get minus 5a, which is the middle term. So this equation is just a minus 2 times a minus 3 cannot equals to 0. As a result, it means that either a minus 2 cannot be 0, or a minus 3 cannot be 0. Which means that a cannot be 2 or a cannot be 3. Now this is already an answer to our first question. We said that the function can be defined everywhere except where we divide by 0, because only division by 0 in our case is undefined. So the function is continuous at all values of a except for 2 and 3. So function is continuous at all values of a except 2 and 3. Alright, but then remember, even though the function is continuous at those points, we can still even though the function is discontinuous at these points of 2 and 3, we can still have a limit. Remember this from the previous graph on the concept of continuity. When we had this something like that, we have xy axis, and let's give an example right for our case. Let's say this would be 2, and then this would be 3, and this would be our f of x. This is how it could look in our example, that for the values when x equals to 2, the function does not have a defined value, and for x equals to 3, the function again does not have a defined value. But the limit as we go from the left and from the right approaches the same point, approaches the gap. So in our case, the limit can still exist and the function be discontinuous. So that's what we're gonna look for in the second question, and let's do it in the next video.